Hey all, this is part 2, and we're going to be using the accumulator pattern to solve some coding challenges. So this one is filter odd elements. Write a function called filter odd elements. Given an array of numbers, filter odd elements returns an array containing only the odd numbers of the given array. If the given array contains no odd numbered elements, your function should return an empty array. So let's go ahead and check out our accumulator pattern. First thing, identify the inputs and write a function definition with those inputs. How many are there? What are their types? So with that in mind, it looks like the input to this function based on the test case and the description is going to be one array of numbers. So I'll say, oh nuts. We'll say one input is one array of numbers. With that, I can write my function definition, which will be filter odd elements. Now, you want to keep in mind it's essential that you name your function exactly this. If you don't, the test won't give you a very robust output. So filter odd elements looks like it takes in an array of numbers. I'm just going to call it numbers. And that looks like that's it for the first step. Let's check out step 2. Identify the output. What will the function return when the input is normal? What will the function return when the input is empty? Now, one thing I'm going to assume, based on the problem definition, is that we're not going to deal with any edge cases. There's no version where the input comes in without any numbers in it. They might all be even, but I would prefer that our algorithm is going to take care of that. So nothing to worry about for the edge case. But what will the function return? Will return an array of odd numbers. So good. Define the result variable and return it. Initialize it to whatever the output is in the empty case. Now, we're not worried about this, but we will initialize it at a, well, I guess the empty case is if we don't find any odd numbers. So the empty case will just be an empty array. So with that in mind, we'll say create result array, and that can be variable odd numbers is equal to an empty array. And then down here we'll return that. So odd numbers. Excellent. One thing we did forget to do was grab our test case, so let's go ahead and do that now. Excuse me. And I believe we are on step, initialize to the empty, okay, so we did determine how to iterate, how many times you're going to iterate. Let's think about it. If we have an array of numbers, I want to look at all of the numbers, so we should say something like iterate over every value in array of numbers. Excellent. Now, how to iterate? For loop. Since because it's an array and we want to look at all the values, might as well just use a for loop. How many times are you going to iterate? Maybe that refers to, rather than iterating every value, sometimes you would want to do every odd, or every other, every third value, but for this one it's going to be every value. So we've sorted that out. And it looks like they want us to actually write the form of iteration. So we'll go ahead and do that. I is equal to 0, I is less than numbers, dot length. In the next couple of problems, we're not going to do the accumulator pattern as explicitly as we are for this one, where we're looking back to the code, to the documents each time. We're just establishing the idea. Create a result, return the result, iterate, and yeah. Alter the accumulator, and this one's a little too specific for our purposes, but we want to alter the accumulator using the information. And this is where the, what you actually do is highly dependent on what the problem's asking. So for this one, this is where we affect the accumulator. And the way we're going to do that is first we need to check to see if current value, which is a way for us to say in pseudocode just whatever number is at I is, or whatever the array is at I. Those are very convenient ways for us to structure a blueprint for our code such that it's easy for us to fill in code afterwards. So if the current value is, what do they want, odd, then we will add current value to result array. And that's pretty much it. So once we have that in place, let's get our if statement. Let's wrap it around. So current value is just going to be numbers at I. To figure out if it's odd, we're going to apply the modulus operator with 2 and check to see if that's equivalent to 1. If it is, we know numbers at I is odd. If numbers at I is odd, then we would add it to our numbers array. So numbers, odd numbers. Dot push is the method that'll add a value to that array. And then we're going to say numbers at I. So if we do that, that should be it. And we know we've done everything because we planned our pseudocode from top to bottom and from beginning and end working towards the middle. We know we return at the end, we create it here, we iterate over the input, and then based on some condition, we affect our accumulator. So that's the pattern. Let's go ahead and run it, make sure that we get 135. One of the things that it said was that if it contained no odd numbers, it should return an empty array. So let's go ahead and check to make sure that happens. So this should return an empty array, and it does. So let's go ahead and copy. And to be sure, it's not actually the world's greatest idea to do what I just did. And the reason would be that let's say that you change the values here and you find you have an error. If you then go back and adjust the function and then get your test to pass with having replaced the first test, it might be the case that you're just kind of like switching a light switch where it goes from passing one test to the other, but you're never really getting full completion. So what I would suggest is usually to copy and paste your test cases and make multiple versions if that's the route you're going. But with that in mind, we have completed our function. So let's take it back to the input window. You have to, I can't overemphasize how important it is to write filter odd elements correctly, to name your function exactly what's said here. The tests are really not going to give you much of a nice output if you don't. And actually, let's go ahead and see what happens if we don't. So I'm going to say filter odd element. I think what should happen is it's going to be like, oh no, it does give you a nice output. Okay, yeah. So name your functions with reckless abandon because these will help you out. So filter odd elements. We run the test for this one, and we're in good shape. So that's the accumulator pattern. In the next couple of parts of this lesson, we're not going to be going as explicitly off of the docs. We'll just kind of do a general approach. But with that in mind, thanks for watching. Hope you enjoyed it, and we'll see you in the next one.